So, hello everyone. In this video, we're going to learn about sets of numbers. But first, what does it mean by sets of numbers? Well, a set of numbers is really just a group of numbers. So here's a quick tour of how numbers fit together as a set. Before I continue, which set are already familiar to you? Okay, now let's discuss together each set. Now, if you can see here, I also attach a diagram, a rather small one, so that you can see how each set relates to each other, okay? Now, our first set here is the natural numbers. Natural numbers were invented first because we use it for counting. And that's why it has another name of counting numbers. Now, it is super easy to remember natural numbers. Think of it this way. People naturally count things started from 1, 2, 3, and so on, counting numbers. So example of natural numbers are any counting numbers that you can think of. 8 or even 5,000 and so on. Okay, now apparently only counting numbers are not enough in our world because like what if we want to know the answer of 5 minus 9? Now, hence, we invent the next sets of numbers, the integers. So integers are the whole numbers and its opposites. So it will contain the natural numbers, zero, and also negative numbers. Can you give me examples of integers based on the definition? Okay, here are some examples. Negative 51, 0, 737, and so on. Okay. Now, the need for mathematics continue to rise. This time, how about if we want to describe parts of whole? Now, parts of whole are fractions. So our next set is the non-integers. Non-integers are the fractions. Examples of fraction, 1 out of 3, 1/3, -1 out of 7, and don't forget even a decimal like 5.2 is also a fraction because we can write it in its fraction form, 52 out of 10. So that's the non-integers, the non-whole numbers, the fractions. Now, if you see here, integers and non-integers, together they make the rational numbers. Rational numbers are basically any numbers that can be represented as ratio, can be expressed as ratio. As ratio. Yeah, we usually write this as P over Q, where P and Q are integers and Q is not equal to 0. Yeah, because a fraction like 2 over 0 are undefined. Now, so the example are any fraction. I'll just randomly write the fraction here, or even a decimal, just like the non-integers, yeah. A decimal like this, 0 point repeating 3. Now, you know, we can rewrite this as a fraction, 1 out of 3, and also a decimal like maybe 4.156, 8. They still can be represented as fractions, right? Over 3, 4. Okay, now we've done with the rational numbers. For the numbers that cannot be expressed as ratio, we call them the irrational numbers. Now, irrational numbers is just the opposites of rational, cannot be expressed as ratio. What are the example? Numbers that cannot be expressed as ratio. Square roots of 2, and then cube root of 9, and pi. This number cannot be expressed as ratio. Like the first man who proved that square root of 2 cannot be expressed as ratio is Hippasus. You can search more about him. Interesting story about him. Next, if you see here, under irrational numbers, we have sets of radicals and sets of transcendental number. Let's discuss more about it. So radicals are roots of integers. It can be, oops, oh no. Okay, roots of integers. So it can be square roots, cube roots of integers. Example, cube root, negative cube root of 11, or square root of 14, and so on. Now, meanwhile, the transcendental number are the ones that cannot be expressed as roots of integers. Oops. So you see, transcendental is the opposites of radicals. Yeah, I'll just write the example here. Example, the pi. Okay, so rational numbers and irrational numbers are subsets of real numbers. Real numbers are all the numbers that can be put into number line. They have points in their number line. Now, so, well, any numbers here, if you see real numbers are like the larger sets than any sets here below. So, example can be anything, yeah? 0, 5, or maybe the pi, or the square root, and so on. Now, there are numbers that cannot be put in the number line, that don't have any points in the number line, and those are the imaginary numbers. What are the examples? The example is square root of negative 1. Can you put square root of negative 1 in the number line? We don't have any point in the number line for square root of negative 1. Or maybe square root of negative 49. Careful with that, yeah. The 49, we can find the square root at 7, but it's negative 49, so cannot. Okay, the complex number are the larger set from real numbers and imaginary numbers. So we can express this as A plus BI, where A and B are reals, while I is the negative 1 or imaginary numbers. Example, it can simply be like 3, like the real numbers, because we can express 3 as 3 plus 0i, right? Or maybe we can write 8 minus 2i, or negative 4i, and so on. That's the complex number. Okay, so those are all the important sets that we have. I know if you notice, I did not discuss everything, but at this point, I hope that you already knew the other subsets, the other sets, because we often use them. So digits are the one that made up the numerals. So the digits are the 0 to 9, which from it, we can make any numeral that you want. Okay, that's digit. Even number are those that is divisible by 2. Like 4, 70, 86, and so on. The odd numbers not divisible by 2. The 1, 3, 81, and so on. positive, greater than 0. 0 is only 0, and negative number less than 0. Okay then, so those are the sets of numbers. I hope this will help you like in the future lessons. So we have a same language in our mind. When I talk about natural numbers, real numbers, you already know what it means, okay? And I hope it helped you. And I see you in the next video. Bye-bye.